Our first target customers are AI startups building agentic products, enterprises who want to deploy AI agents autonomously without actually losing control over them. For these customers, the problem is not simply accessing an intelligent model, it is controlling what AI is allowed to do. Coordinating multiple AI agents, managing failures, and knowing when human approval is required. This is where ethical AI creates value. In this generation, the question is not can I as this was a simple question, the answer is also simple, just like how ChatGPT or any other AI model would answer it. Ethical AI uses previous conversations to gain knowledge about the user and use that as context to answer future questions. For the next prompt, I'm going to ask ethical AI to give me a deep analysis on EV cars and their future. Also, I wanted to compare it against petrol cars. As this task requires deep research, ethical AI is going to assign different tasks to different agents working simultaneously. According to the prompt, the ethical AI suggests two different agents that can be used for this. One is a research agent and one is a analysis agent. Before executing, ethical AI gives the user the brief of what processes it is going to use. According to the prompt, Nexus both checks and fixes the resources required for the task. Nexus suggests us what agents to use for this particular task. It also gives us the opportunity to select which agents to use or not to use. Matrix is the security layer of ethical AI. It controls what information, resources, an agent can access, ensuring every action operates within defined security boundaries. On top of that, Helix provides governance. Before an action is executed, Helix performs policy and risk checks to determine whether it should be allowed, blocked, or sent for human approval. Together, Matrix secures access and Helix governs action, creating a control boundary between AI decisions and execution. This is the execution page, the point where the plans generated by ethical AI are actually turned into action. Once the mission has been understood, broken into tasks, and passed through the security and governance layers, the approved workflow reaches its execution stage. Here, the AI agent performs their assigned tasks according to workflow generated by the planner. Instead of treating the entire mission as one black box, we track execution at the individual step level. This allows us to see which task is currently running, which tasks have completed, which are waiting, and when an execution failure has occurred. This visibility is important because a successful response from an AI agent does not necessarily mean that the underlying task was successfully completed. The execution page therefore reflects the actual state of the workflow rather than simply displaying the agent's response. Another important part is human in the loop or HITL. When an action crosses a risk or policy threshold, the workflow pauses for human approval or rejection, balancing autonomy with control. Nexus OS manages the workflow state, dependencies, and execution status, while verification confirms whether the expected outcome was actually achieved. So this page brings together execution, human oversight, failure visibility, and verification, ensuring AI just doesn't act, but acts in a controlled and verifiable way. For this example, we didn't use HITL or human in the loop as it was a low level research prompt without any human supervision required. Let's take a hypothetical scenario where HITL might be required. So imagine an AI agent is asked to process a financial transaction. The agent can handle the preparation automatically, but if the transaction exceeds a predefined amount or involves a high risk amount, Helix triggers a policy check and pauses the workflow. A human can then review and approve or reject the action before execution continues. This allows routine tasks to remain autonomous while keeping high impact decisions under human control. For ethical AI, we have used five different databases. The first one is ElectricDB, used to manage agents and sync in real time. Second one is MongoDB. It does the session storage of metadata of missions. Third one is PostgreSQL, hybrid queries with VectorDB and metadata. Fourth one is VectorDB for searching plus and retrieving data. Fifth one is SQLite. It does a temporary cache, mapping, and embedded files.